Good morning. Am I audible? Good morning.
Good morning, sir.
Very good morning.
Good morning.
Very good morning. Very good morning. So, I think you all are from EC department. Okay. Fine. All of you are from the lateral entry batch.
Yes, sir.
Okay.
Yes, sir.
Okay. So, we'll start our. This subject is circuit theory. Have you got your syllabus? You know how to get this syllabus and all of your department.
Yes, sir.
So from where you have
Yes, sir.
got this syllabus? Okay, fine. So I will just show you a ready-made link where you will get all your syllabus. Okay, with you. You will go to the Chaivasha Engineering College. So this my screen is visible. My screen is visible to all of you.
Sir.
Yes, sir.
Okay, so can you see the syllabus? Can you see the syllabus in the Chaivasha Engineering
Yes.
College?
Yes, sir.
So you will go to the academic, and under that there is a syllabus button. Okay, so you will click the syllabus button. So you will be directed into this page. Okay, so under that it is under JUT syllabus. So JUT syllabus means Jharkhand University of Technology. So you are our college is affiliated to Jharkhand University of Technology. So you will go to your department. So you have EC third semester. Okay, EC JUT third semester. So here you will just download it and you can see your syllabus. Okay, this is your syllabus. This way you can actually get your syllabus. Okay, so we are actually here. I will take your one of the paper, that is network theory. Okay, so network theory paper, under this paper we have 5 modules. Okay, so first module is circuit fundamentals, then resonance circuit, then third one is two-port network, then network functions, and then filters and attenuators. Do you have any concept, anything? Have you read prior to this this subject anywhere in your diploma level? Diploma level, have you studied this subject?
Yes, sir. Circuit fundamentals में कुछ points दिख रहे हैं, वो सब कुछ याद आ रहा है.
Okay, so here we will detail your all these particularly these topics will be discussed in detail. Okay, in your this undergraduate study. Okay, in your BTech. So, student, myself, Dr. Ranjit Roy, principal of this college. Okay, yesterday we have interacted with you, but now we'll straightway start your class because the time span is it is very short because the classes that is as per this admission, we have started now this class, and within 1.5 months we are about to finish this syllabus. So we have to be fast enough so that we can cover your syllabus. Okay, and there will be exam also. So there will be many teachers, they will take your class. So morning you have attended any classes? Morning session prior to my class? Have you attended any class?
Yes, sir.
Okay, fine.
Yes, sir.
Yes, sir.
Okay. So myself and another faculty member, Mr. Chayan Chakraborty, both of us will be taking this paper. So here you see this. I will start with this two-port network. Okay, I will start first this module, two-port network. Okay. So now I will go to the particular topic. Okay. So two-port network analysis. Do you have any concept? Anything do you know? What is two-port network? This topic you have studied earlier? In your diploma level? No, I think you have not studied. Okay.
No, sir.
Okay, fine. If it is no, then you tell. Don't hesitate. Okay. Whatever problem you will face during this online class, please raise your question, raise your doubt. Feel free. Okay. Feel free. We are here to help you if you are facing any kind of difficulty, because this is a new institution. You have just joined this institution. Okay. So you should get familiar with this institution. Okay, and any kind of difficulty while this teaching learning process will help you. You raise your doubt that yes, I have not understood. So we'll repeat that thing. Okay, no issue. Okay, in any subject, you just tell to your teacher that sir, I have not understood this thing. Okay, so we'll start this thing. So first we'll discuss some of the network elements. Okay, these are very basic things. So network element, it is broadly classified into two categories. One is the linear element and second is the non-linear elements. So linear and non-linear elements, network elements, that means linear means the network characteristic something it is linear. Okay, just like a straight line. Okay, the characteristic is seems to be a linear. And similarly, the non-linear network elements, those network elements means the characteristic, the VI characteristic. Now here, when we'll basically say that the characteristic of the elements, that means we actually want to mean the VI characteristic of that particular element. Okay, so for example, if you are getting something, let us say this is a let us say axis, okay, and you are getting something, for example, you are getting this way, okay, and here this side is your I and this side is your V. So what is this element? This is linear element or it is a non-linear element? Please tell me.
Linear elements, sir.
Correct. This is linear element. Similarly, if you have, just I will connect my board, just a minute, please bear with me. I will connect my board. Similarly, let us say another element, okay, where this is your V and this is your I, and the network characteristic is something this way. So what is this? This is linear or this is non-linear?
Non-linear.
Correct. So the VI characteristic actually enables us to identify whether the element is linear or it is non-linear. Okay. So linear elements, what is the definition of the linear elements? A linear element shows linear characteristic of voltage versus current. So just now I have shown you. So for what are the elements? The example of these elements, the simple resistors, inductors, capacitors are the linear elements, and their resistances, inductances, and capacitances do not change with a change in the applied voltage on the circuit element. So usually these resistors, inductors, and capacitors, these elements are the example of the linear element. Okay. Similarly, the non-linear elements. So non-linear element, I have shown you that VI characteristic, it is not linear. So for a non-linear element, the current passing through it does not change linearly with the linear change in the applied voltage at a particular frequency. So we will not be able to get the linear voltage if we change the current linearly. So the example of this kind of element is the semiconductor devices are usually the example of nonlinear elements. So any one of you can tell that any example of the semiconductor device, name of any semiconductor device? Do you know? Because you are mostly you are from EC branch. Okay. So any student, can you?
Diode transistor.
Correct. Very good. Very good. So that is diode transistors. These are the basically semiconductor device. So you will learn basic electronics. So where in detail you will learn that what is the semiconductor device. Now next we will come to the what is active elements. Now active elements. What is the name means basic definition of the active elements? If a circuit element has the capability of enhancing the energy level of a signal passing through it, it is called an active element. So usually these active elements, it is normally used in for the semiconductor devices. Okay, in electronics engineering, this branch normally you are used to boost up all the signals. Okay, signals will be suppose a certain magnitude of signal is there with a certain frequency. So you can modulate that signal to a higher frequency, or you can modulate that signal. You can increase the magnitude of the signal. So there is a possibility that you can actually change the characteristic of that particular signal. So the example of these active elements, this is basically the vacuum tubes, then semiconductor devices such as transistors, op amps, etc. are the active elements. So these are the basically very example of the active elements. Now next is the passive elements. So this element does not have any intrinsic means of signal boosting. So these elements they are having they will not change anything. Okay, there will not be any change in the magnitude, or there will not be any change in the frequency. Okay, so both the things will be absent. So in those cases, we will say that those elements are basically passive elements. So usually that is the example, that is the resistors, inductors, and capacitors are the passive elements. So usually how you will remember this thing, mostly in electrical engineering, the peoples they are doing in electronics engineering also, you will be also handling these resistors, inductors, and capacitors. But active element means which is actually belonging to the transistors family or the semiconductor device family, where the passive elements, these are from the elements which does not change any intrinsic any change in the signal boosting. Those characteristics will be absent. Now next is the unilateral elements. So unilateral elements, what is the definition of this? Because we will first understand what is the network elements. Then we'll enter into the actual network theory or the two-port network, because this is the very basic concept. Now, if the magnitude of the current passing through an element is affected due to the change in the polarity of the applied voltage, the element is called the unilateral element. Okay. So that means if you are suppose passing any current through any network element, and due to that the polarity of the element gets changed, okay, there is an effect. So we'll say that there is that elements are unilateral elements. So the examples of the unilateral elements are basically diodes and the thermistors. Similarly, the bilateral elements, if the current magnitude remains the same, if the applied EMF's polarity is changed, it is called the bilateral element. So what will happen? Suppose you are changing the polarity of the applied EMF, means the source polarity you are changing. So initially it is plus minus, then it is minus plus. Okay, so you are changing the polarity. So even though if you have observed that the direction of the current remains same, then the magnitude of the current remains same, then we'll say those elements are basically the bilateral elements. So examples are the basically resistors, inductors, and capacitors. So I will show you this thing with the help of board so that you can understand this thing. Suppose in a network, okay, you have a source. You have a source. This kind of source is there, plus minus, and you have a resistor. Okay, so this is a resistor. Okay, so there is a current I and there is a voltage V. Okay, now when you are supplying, this is the voltage across this resistor. Okay, this is the voltage you are measuring. Now what will happen? The source voltage is, let us say, Vs. Now Vs is plus minus. So we were measuring the current, the magnitude of the current. So magnitude of the current, it will be I equal to Vs by R. Now let us say you have made this is upper one is minus and lower one is plus. Again, in the second case, you are also measuring the I dash. So second case, let us say the current is I dash. So I dash equal to, again, it will be Vs by R. So that means here the magnitude of the current is I will be equal to your I dash. So that means this network element is unilateral element or it is a bilateral element. Tell me.
Bilateral.
It is bilateral element. So this bilateral element magnitude will not change. Okay, it will remain fixed. So the example of the bilateral element, you can tell. What is the example of the bilateral element?
Resistor, capacitor.
Resistors, capacitors, inductors, those are the basically examples of the bilateral element. Sorry, disconnected. Okay. Next, classification of the network. Now, classification of the network, there is a linear circuit and there is a non-linear circuit. So, linear circuit is a circuit whose parameters remain constant with the change in the applied voltage or current. Then that is called the linear circuit. Now, whereas what is the non-linear circuit? It is a circuit whose parameters change with the voltage or current, then it is called the non-linear circuit. So similar to your linear element and non-linear element. So linear circuit, it consists of the resistors, inductors, and capacitors, whereas the non-linear circuit, it is basically semiconductor resistors, and those things are basically under the family of the non-linear circuits. Okay, so we have understood what is this classification of the network. Now, what is active network and what is passive network? So it is an active network. It is a network which contains one or more than one source of EMF. It is a network where maybe the one source or maybe more than one source of EMF is present. That is let us say battery. And the passive network, when the network does not contain any source of EMF, it is called the passive network. So we can understand that if let us say any source is present within the network, then it is called the active network, and when there is no source is present within the network, it is called the passive network. So a passive network consists of resistance, inductance, or capacitance as passive elements. Now we'll come to the point of the two-port network. Okay, so till now if you have any doubt, please ask me that you have not understood any point. Anyone? Any doubt from anyone? Any doubt?
सर यूनिलैटरल एलिमेंट एक बार थोड़ा सा बता देते.
Okay, fine. Unilateral element. So if the magnitude of the current passing through an element is affected due to the change in the polarity of the applied voltage, the element is called a unilateral element. Now, what is bilateral element? If the current magnitude remains the same, even if the applied voltage of the EMS polar or the polarity is changed, it is called the bilateral. Simple way, I have just now shared this thing. I will share with you the same thing. This one. So here you see, initially it is plus, it is minus, and you are having a resistor. So you are measuring the current. So current equal to I equal to Vs by R. Now what you have done, you have changed the polarity of this source. So this is minus, this is plus. Again, you are measuring the current. That is I dash. So I dash will be equal to Vs by R. So in this case, we can understand, though if you change this particular source polarity, there is no change in the magnitude of the current. Okay. So magnitude of the current remains same, though the direction will change. Direction will be, initially it will be this way, but when you have changed this minus to plus, this will be in this direction. So the direction will change. So what we have understood, if let us say if there is a change in this particular, if there is no change in the magnitude of the current, then we'll say that element is a bilateral element. If there is a change in the magnitude of the current, then we'll say that is a unilateral element. Unilateral element examples are basically the semiconductor devices. Now it is clear?
Yes, sir.
Okay. So now we come to the point of the two-port. So two-port network, it is basically, from the name it is clear, that is there are two ports. Okay, there are two ports. Two ports means there is a one input side and there is some output side. So that input and output, in between you have the all the network, or the basically the elements are connected. That is basically a black box. So from the figure you can see, this is your input. This is voltage. Input voltage is V1 and input current is I1, whereas the output voltage is your V2 and output current is your I2. So your input and output, these are basically two different things. Okay, there are two ports. Okay, this is port 1 and this is port 2, and in between this is a black box. So all the network elements, they are basically dumped into this particular box. Okay, so what is the basic definition of this two-port network? A two-port network has two pairs of terminals. Two pairs of terminals will be there. One pair at the input, known as the input port, and one pair at the output, known as the output port. So input and output, basically this is a pair of terminal. That means there are two terminals which is basically considered to be as the input port, and there are two pairs of terminals at the output, that is to be considered as the output port. So these two ports are there, and in between we have the all the network connections. So how this network will behave, what is the different kind of different types of analysis, so that we'll see under this two-port network. So there are four variables. What are the four variables? V1 and V2. That is your V1 is the input voltage and V2 is the output voltage. I1 is the input current and I2 is the your output current, which are associated with the two-port network. Now, two of these variables can be expressed in terms of the other two variables. So this is the very interesting thing which you will basically learn in this particular topic. So there are basically four variables. So four variables: input voltage, output voltage, input current, and output current. Now, how this input voltage and output voltage, how they are correlated, how they are basically, what is the relation between these voltage pairs of elements and the current? So these particular interrelations will be actually discussed in this particular chapter. So we'll see that how this network, these parameters, how they will behave, okay, and how these input and output variables, they are interrelated with each other. So that is basically we'll understand with the help of different kinds of parameters, which will be discussed very soon. So thus there will be two independent variables and two dependent variables. So obviously, suppose for example V1 and V2, these are expressed in terms of I1 and I2. Okay, so now can you tell which one is dependent variable and which is independent variable? If V1 and V2, these are basically expressed in terms of your I1 and I2. So let me come to here. So for example, this is your V1, V2. This V1 and V2, they are function of I1 and I2. So can you tell that which one is your dependent variable and which one is independent variable? Which one is dependent variable?
I1, I2 is dependent. Independent variable and V1.
Correct. I1 and I2 is the independent variable. Correct. Very good. Very good. And V1 and V2 is the
Dependent variable.
so dependent on what? I1 and I2. Okay.
Dependent on I1, I2.
Yes.
Correct. Correct. So it is dependent on I1 and I2. So we'll see that thing, that how they are basically dependent and how these network parameters will basically change. We'll see those things. So in this two-port network, we'll study various types of parameters. What are those parameters? First is your Z parameter. It is known as the open circuit impedance parameter. Then we'll study Y parameter. Then we'll study the hybrid parameter or the H parameter. Okay. And we have the another parameter that is known as the ABCD parameter, or that is known as the transmission parameter. Okay, so I think we'll be disconnected within 10 minutes. So we have the 10 minutes time. Okay, so in between, I will just take your attendance. Just a minute. I will just take, because within 10 minutes will be disconnected, because this is the time limit for this particular thing. So now we'll start. Okay. So are you facing any difficulty to join in the class regarding this class link? No, no. You are comfortable, na, with the joining the classes, various classes?
Yes.
Okay. So actually we have shared your routine. Okay. Yesterday we have shared, but anyway, we'll actually teacher wise we'll give those links so that it will be easy for you to connect to the particular link. Okay. Now this jet parameter for the two-port network, the input and output voltage V1 and V2 can be expressed in terms of input and output current I1 and I2 respectively. So here basically this input voltage and output voltage, they are basically correlated, or they are basically expressed in terms of input and output current. So here V will be equal to Z into I. So V is the basically the voltage matrix, then it is equal to the impedance matrix into the current. Okay, basically V equal to I into Z. We know this thing. V equal to IR. So V equal to I into Z. Z is the impedance. So when in a AC network, we usually it is called the impedance. Okay. So how they are basically related. Okay. So this how these network parameters they are basically related. So we'll basically understand this thing. So your V matrix, this V matrix, this is equal to your Z matrix into I matrix. So that means what are these variables of this V matrix? This is basically your V1 and V2. These are the two variables. The V1 is your input voltage, V2 is your output voltage. And this is your Z11, Z12, then Z21 and Z22. And then you have an I1 and I2. Now, what is this Z11, Z12, Z21 and Z22? These are basically the impedance parameter of this particular network. Okay. So if we write the equation, V1 will be equal to, so this will be multiplied with this. So that means Z11 into I1 plus this will be multiplied with this. So this will be Z12 into I2. Then V2 will be equal to, this is equal to Z21 into I1 plus Z22 into I2. Is it clear? Any doubt on this particular Z parameter till now? Any doubt?
No.
Okay, fine. So we can express the input voltage and output voltage in terms of input current and the output current. So you see, this way we can represent this thing in a matrix form. So now we'll know what is this parameter. What is this Z11, Z12? Okay. So Z11, how we can calculate this Z11? So Z11 can be calculated if I2 equal to 0. So if I2 equal to 0, then we can calculate Z11 equal to V1 by I1. And this V1 by I1, it is known as the driving point. This is known as driving point input impedance. This is known as driving point input impedance. Okay. Similarly, if you see, if you make this I1 equal to 0, so I1 equal to 0, so if it is I1 equal to 0, so what will happen? I will write this equation again. U1 equal to Z11 into I1 plus Z21 into I2 and V2 equal to Z21 into I1 plus Z22 into I2. So if you are putting this 0, so what will happen? This Z22 equal to V2 by I2. So this is known as the driving point This is driving point output impedance. Is it clear? What is driving point input impedance and what is driving point output impedance? Okay. So this way you can calculate Z11 equal to driving point impedance with input open circuit. So I2 equal to 0 means your output side, it is no current. Output side, if it is no current, then it is also known as the open circuit condition. So when this output side is open circuited, so that means if output is open circuited, there is no connection in the output side. So what will happen? This particular means V1 by I1, this value is known as the driving point input impedance. And it is also called the open circuit reverse transfer impedance. So forget about this particular thing. We'll calculate. You just remember this is driving point input impedance. Similarly, Z22 we'll calculate, that is when your I1 equal to 0. So this is equal to V2 by I2. So Z22 is known as the open circuit driving point output impedance, where output port is open circuited. Okay, with the output port is open circuited. So here you see it is wrongly written. It is input port. I1 equal to 0 means it is input port is open circuited. I1 0 means there is no current in the input side. So input is open circuited. So input port is open circuited. So please correct this thing. This will not be output port. This will be input port. Now similarly, Z21 and Z12, how we can calculate? Z21 will be equal to when you will put I2 equal to 0. So this is V2 by I1. So Z21 is the transfer impedance with the open port, with the output port open circuited. So output port I2 is 0. So this is transfer impedance V2 by I1. So there is so current is measured at the output port and voltage is measured at the output port and current is measured at the input port. So you are going from 1 to 2. So from your input is 1 and output is 2. So this is forward path. It is basically, this impedance is also called open circuit forward transfer impedance. This is a forward path transfer impedance. Similarly, when Z12, if you have to calculate, then I1 equal to 0. So see, same equation, I1 equal to 0 and I2 equal to 0. From that you can calculate. So I1 equal to 0, then that is equal to V1 by I2. So here we can understand that Z12 is the transfer impedance with the input port open circuited. So input port I1 equal to 0 and it is called the open circuit reverse transfer impedance. Why it is reverse? It is input is at I2 and your output is at V1. So that is the input voltage. So you are going from 2 to 1. So that's why it is reverse transfer impedance. Okay. So these are the basically 4 network parameter under this Z parameter. So do you have any question? Anyone? Do you have any question? Any question from anyone? Hello?
Sir, after class we will provide notes.
Hello? Yes, please.
Sir, after class will you provide notes?
Yeah, definitely we'll provide. We'll create a Google Classroom. Okay, we'll create a Google Classroom, and that Google Classroom, everybody will get these notes because these notes will be required. Today I have started, so we will get it. Definitely will get it. Okay, we'll create a Google Classroom for you. Okay, so that you can access these notes. Okay, because today we have started and few things we have covered. Okay, so any doubt from any question? Because you are basically new to this institute. Okay, so you can ask me any question. Okay, if you have any query, anything, you can ask. Okay, so I think there is no question. So the time is also up. It is within 1 minute it will stop. So thank you. We'll close this meeting. Okay, next class we'll meet.
Thank you, sir.
Thank you, sir.
Thank you.
Okay. Okay.
Thank you, sir.